Hello.
Muted. Yeah, I was muted.
Don't worry. So today, my students, they're gonna present. I asked them because they got a very good training because one of them is gonna have a qualification this month, so he needs to train, and so he's gonna present for you. And Samuel, I said, don't know.
Samuel?
Yes.
Okay.
And I hope that is what you expect.
Yeah, it's just about one of the things that you mentioned, that this is also for training students, right? We want to train students, we want to get them on board. And if it will help, yeah, it's fine. So, and the presentation is about GNSS receivers or some other thing.
Yeah, they're gonna present on some previous primary results of the work they are proposing to do, because they are gonna qualify for a doctor. So he's gonna have a qualification if he can qualify yet.
Okay.
And the other thing I think is important for him because he's also from Ghana, so he's gonna be working in Africa countries and where have a low density of the sea. So it's important for him that these projects have success.
Yeah. Excellent.
And then I invite my team.
Okay.
So okay,
Mhm.
actually it's
Hello,
our
Jonah.
team. And
Hello, Jonah. How are you?
Hi, Claudia. Good to see you.
Good to see you again.
It's been a
How
while.
are you? Yeah.
Claudia is together with me. We're doing our project together here at Univap.
Okay. Oh,
And
Claudia is in Univap now.
yes.
No,
Oh, okay.
Yeah, you
not
are
exactly.
yeah, you are in Univap. You are,
Yeah. Virginia
I'm a
is like me.
collaborator.
yes, she's a collaborator. She's
Yeah.
a research collaborator,
Excellent.
and we are
We shared some
advising.
students.
Yeah.
Hi, Solomon. Hi, Patrick.
Yeah, I can see
Hi.
Patrick there. Yeah. Patrick, how are you? Yeah,
And
the next 10 minutes
use-
is actually for welcoming and recognizing everybody.
Hi, Jenka. Hi, Jenka's here.
Feel free to say hi to
Hi.
someone.
Hello again.
Hi, everyone. Good morning. Good morning to everyone.
Hi, good morning.
Maybe I should
Good morning, everyone.
Yeah, let me unshare my screen so that everybody can see
Yeah,
each
good
other.
evening, everyone. It's evening here in Nigeria.
Perhaps, where are the students?
No way. I was supposed to unshare this. Okay, so um, stop sharing.
Solomon is there.
Okay, so this is better view. So we can,
Oh, good.
Yes, yes. Now you can see. Now people can open their account, their
exactly.
cameras, and for you.
Yeah, I can see Pavel too. Pavel is around. Hi, Pavel.
Hello, hello.
Yeah, good to have you here. I can see Stella is there. Yeah, Yinka
Hello.
is there. Yeah.
Stella. Hi, Dinesh. Dinesh. We met in summer
Hello, sorry.
conference.
Yeah. So
Good
this
to
is my
see you.
first, yeah, good to see you all. This is my first time to join this meeting. I mean, this program. So I'm very
Excellent.
excited,
Yeah,
but
you are
I'm
welcome.
located in Tokyo. It's midnight.
Wow.
Oh, good.
Oh, you
So
are going
it's
to be presenting next week. I mean
next month.
next
Yeah,
month. Yeah,
next
yeah,
month.
yeah, yeah. I
Yeah, yeah,
remember
yeah.
that.
Yes.
Yeah, thank you.
So, so yeah, I will try to at least I can attend the next half an hour, but I try.
Yeah, we're going to
Yes.
be very, very brief, and we
Yeah.
hope to not waste people's time. For now, we are in the introduction mode. We have 10 minutes for that to get to know
Okay.
everybody.
Yeah.
Because that is one of the purpose of this
Mm.
meeting, to get to know each other, and
Yeah.
so that by the time the project is launched, we will be already on board
Collaborate.
to identify who the instrument to go to, and that is the purpose. Try to speak up if you need to speak.
Mm.
Just feel free
Yeah.
to hear your voice.
Mm.
And it's also good
Hello,
for
everyone.
we can increase our network also and make new collaborations.
Yes. Yeah, that's international collaboration. That is also one of the objectives here. So CONGA is instrument based, but when you use the instrument, you can also identify somebody to collaborate with internationally. So, and I have Leslie here. Leslie is the program manager, and he's also here to moderate this. Todd is here too. Thanks, Todd, for coming. I know you are very busy. Yeah.
You bet.
Yeah. And yeah, Leslie, that's Leslie.
I'm the project manager, not the program manager.
Yeah, project manager.
I don't get to control any money.
Yeah, the program manager is
Haven't identified yet.
yes. Okay. And yeah, we have 3
Where's
more
Samuel?
minutes.
Samuel and this five, where they are not here.
If you are here for the first time, you can please introduce yourself if you want to.
No?
This is
Information.
Can I introduce myself?
yes, for
Yeah.
sure.
Hello, everyone. My name is Stella. I'm a PhD student at INPE. I am interested in low latitude ionosphere, and my advisors are Dr. Claudia, Dr. Fabio, and Dr. Bruno Nava.
Well, welcome, Stella. Nice to have you here. I know you use a lot of GNSS instruments, so this is very important for you.
Yes, yes.
Hi, Solomon. Solomon is there.
Yeah, Solomon from
Ghana.
Ghana, yeah.
Well, I know part of you, but I think that, well, let me introduce myself. I'm Claudia.
Mhm.
I'm a researcher in Brazil. I'm in the Virginia's Klausner team now. And our subject are the low latitude ionosphere using multiple techniques, ground-based and satellites. And the part of our students are here and presenting something for you. So, well, and Jonah, Virginia, generally we share some students
Yes.
and collaborate.
Yeah. Yeah, just to say, I'm originally from IMPI, so I know most of the IMPI people from Brazil. So that's 7 years ago now that I had my PhD from IMPI. So yeah, good to see most of my colleagues, my advisors and professors as well. They are here. I have Patrick is also there. And yeah, we have
I think Samuel just
It's
coming,
coming.
just coming in the meeting.
we have a lot of, so if you are here for the first time, we have 2 more minutes to introduce yourself, and then we'll hand over to Gina and our team.
Yeah, I can introduce myself. My name is Virginia Clauster, and I do research in mainly using signal processing. I usually process like magnetometer data. And I just starting like together with Claudia to work with that. And in my master I use some Ionosalt data, but my specialty is signal analysis.
Excellent.
Visual.
So it would be good if you can mute yourself. If you are not talking, it would be good to mute yourself. So today, let me see. Let me just share my screen. Today we have Dr. Klausner, and she's here with our students. So together they will be presenting to us some science subjects and how this CONGA they can benefit from CONGA in the future, and how they can contribute to CONGA. And yeah, so, and after that, we will have the open discussion. We have some updates from the internet team, and then we have some open discussion. So, Virginia, if you can take the floor.
Okay.
Yeah.
So today I'm gonna ask for my student Samuel. He is a doctor student. He didn't do yet his qualification, so he's the beginning of his research. And as a training, I asked him to give an overview of the Brazilian instrument in the Brazilian agency, and after show his preliminary results. Okay, so I will invite Samuel. Can you habilitate him to share the screen?
Yeah, you can share the screen, yes.
I think you must stop sharing yours. So
Okay.
he can share. Okay, Samuel, can you present, please?
Okay, Professor.
Let's see. There is noise kind of somewhere.
Yeah, I think enable me so that I could share.
Oh, you cannot share, just share your screen. Okay, why is
I think you
I think
need
you
to
have to
stop
unshare
there.
your screen first.
Yeah.
Dr. Jonah, you have to unshare your
Yes,
screen.
Okay. Oh, stop.
I think you have to.
1 second.
And I also ask for the other students, Tesfai is here. And if Stella wants you to, during the presentation, say something, you can, okay?
Stop sharing. Oh, okay. Hold on. I need to stop sharing this, but it's eating somewhere. Open multiple can share. Okay. Okay, so you can share now. I think you can share. Just share your screen.
Yeah, it's okay.
Yeah. Sorry about that. Can you share it now?
Yes, please. A moment, please.
Okay. Oh, excellent.
Okay. Thank you for this opportunity. I really appreciate the chance to showcase my research work I am doing in Brazilian sector. First and foremost, I will try to my regards, my greetings to everyone. Good afternoon, good morning, everywhere you are. The objective or the subject matter of my research is to talk about the essence of the ground-based instrumentation availability in Africa and South America. My name is Abaidoo, and I am being guided by Dr. Virginia and Dr. Claudia. The overview of my presentation will be a brief introduction to instrumentation over South America and Africa, the advantage of combining both sectors' data, and some brief summary. This image shows a brief pictorial overview of a laboratory located in INPI called LIT. The purpose of this lab is for manufacturing, for assembling, and for testing of space instruments for space observations. This is actually at INPI, and it was opened, I think, around 1987, on December, and it is observed at the ground floor of the facility. This is part of it. These are various instruments or other tools in which they assemble instruments and also for testing purposes. CIMAG, you also find a sensor. I think the launch of South Africa satellite in September 2029. And according to space consultants in Africa, since the launch of satellite in, I think, over for the past 20 years, only 44 has been launched into orbit, and it is only by 13 African countries, which South Africa is leading. Space instrumentation can be classified either by ground-based instruments or space, as I mentioned before. Ground-based instruments, some are the Earth images, magnetometer, the ionoson data, the scatter radar, and the others. For the space instrument, you see from the heliosphere to the space environment, you see the various satellite systems taking or monitoring or taking images in which these satellites are being received at the ground base as the GPS systems. So here you could see the gold satellites, the time, the AC, the SAHO, and other satellites in operation, which is orbiting our space environment. This is a space practice center, also recognized at INPE, South America. The purpose of this is for briefing of atmospheric phenomena and other atmospheric predictions based on the data they are being collected.
How you guys doing today?
Good.
All right, let me start with Deanna first. How's she doing?
She's doing better since the last
The
time.
ground and the other receivers. This space practice center at South Africa also for briefing of space phenomena and
You only use the medication right?
based
Actually, every day. We put a little bit every day.
Sorry about
now,
that.
how does this sector, the importance of why this sector relate, and we should consider by installing instruments in Africa for purpose of research as follows. It could help to coordinate observational campaign and field experiments involving instruments for analyzing or for studying specific ionospheric and space. Now, it could also help to establish a partnership between institutions, between colleagues by sharing information. And what kind of information? Data information, also other our Earth environment. It also helps in understanding of ionospheric variabilities and improve prediction capabilities based on the time data. Okay, you know that the red time between Africa and South America is, Africa is leading. So if you are able to consider these two sectors by installing data over Africa, it could help to understand the ionospheric variabilities over that place. It could also facilitate the exchange of ionospheric and space data, space weather data, including models. This image shows we need a lot of satellites receivers to achieve our purpose as a space physicist. It's very important. This shows the location of magnetometer network in Africa and Saudi America. Just like this is okay for this one and showing verification of where the instruments are being installed. My right corner shows that Africa where the that being installed. Network. Present a brief summary of some results we are collecting in order to justify the importance of installing a ground-based instrument in Africa. So that much I do. I will go back. This figure actually shows the distribution, global distribution of gravity. Okay, in globally, I think to show the variabilities in both sectors, we see that it's been, if you check the distribution, the distribution is more concentrated in the mid-latitudes, if you can see. And when we talk of sporadic key, they are formed by meteors. Okay? So when these meteors hit our Earth environment, they are deposited as metals and therefore undergo charge exchange. So when they undergo charge exchange, they become ionized and later become concentrated and deposit as a single layer in the G region. So that particular sporadic key is being formed. And for better understanding or for verification, we intend to acquire instruments on both sectors for us to able to understand the dynamics, the distribution dynamics and other important information which could help us to space properly. This image shows an atmospheric latitudinal, could see the intensification of electron density. And if you could go deeply or watch it carefully, you could see that the intensification is being observed at low latitude region. This could be attributed to storm, geomagnetic storm. And as you could mention, there are disturbances in the atmosphere when there's exchange of energy from the solar wind to space environment surrounding the Earth. So we could see the intensification of the electron density, and we can also see that the equatorial ionization anomaly is also intensified. Actually, storm occur when there's magnetic reconnection happen between the Earth's magnetosphere and interplanetary magnetic field. And when the interplanetary magnetic field rotates southward and lasts for several hours, storm is being occurred. And this storm is most importantly, and most at times, is being actually ME. That is one storm driver. And another storm driver, which we could talk about, is CRR, which we presented case study over it, I think, America. In South America, case study, which was based on the CIR-driven storm. CIR, the co-rotational interaction region, is structure in the helisphere, which normally happens in the declining phase or descending phase of solar cycle. Okay, they occur in response to the interaction of high solar and low solar speed streams. And they are emanated from this speed, or this type of high solar wind speed emanated from the coronal hole. They are low and they are low dense region, and based on their behavior, they act as a collisional plasma outside the outer surface of the sun. So, from the top bottom to down bottom, the interplanetary magnetic field, the interplanetary electric field, the symmetric cage measure the intensity of the storm, the plasma frequency, the tech, showing the variation of low latitudinal region in Brazil, that is Cachoeira Paulista and Brasilia. So in the main phase, we could realize that the initial phase of the storm was around 4 o'clock universal time, and the main phase was recognized around 22 universal time. So in the main phase, we see an uplift, the intensification of the plasma frequency as well as the tech. And over the intensification, see the current day was higher over the 5 quiet times day. In fact, this was Cachoeira Paulista, and this also, so we could see the intensification which is being caused by the CIR storm. This is located in the low latitude region in Brazil. And we could see a long recovery phase. And this long recovery phase is one feature of CIR storms. This one also shows an atmospheric behavior in response to CIR storm in São Luís, that is Brazilian region. You could see the intensification, or you could see the uplift over the 5 quiet times day, the virtual height, the peak height of F layer, and the plus frequency. Remember, when you observe the more, the CIR storms they are normally a moderate storm. I think, and in our work, it was around -100 nanotesla for the DST value, and it was having a long recovery phases, and these long recovery phases are being characterized by HERGICA, which is high intensity, long duration, caused by auroral activity when there is an intensity, when there is an intense storm. Okay, it normally happens. You could see a very they're being uplifted in the recovery phases, and one could say that here on the electric field and the B, you could see a minimum or no significant value or no fluctuation at all. The fluctuation is not insignificant. But if you check the intensity of DST value, you could see it is value over there. And it's also a significant parameter which we could consider that the uplift over here can be attributed to that. So there wasn't any significant value. The fluctuations observed in BZ and BY wasn't much though. Now the advantage of combining both sets in research study could help to present an excellent opportunity for collaborative and research cooperations, and it will play a crucial role in comprehending the patterns of atmospheric dynamics. And for comparative analysis, it's very important to consider both sectors. It will also enhance the quality of space forecasting and other services, and the exploration of longitudinal variations between these two sectors can also be identified and well studied. It could also foster a development in sharing space weather prediction models and other information which will be relevant for our field research. Some of my presentation could be, you see, when we combine these sectors and when we use base for our research or future work based on what I presented, you could see that if you put data in Africa, it will be very good analysis to dynamics or the variabilities in that sector and here, and it will be a very good work in future. So it will call an effort over the potential to discover new ideas, as I mentioned. Okay, so it will also help students and space practitioners the opportunity to enhance their skills and expertise very properly, and it will also collaborate. The collaboration will provide an avenue to explore unique characteristics of features in atmospheric studies in both regions, and contribute to the PVT, that's the positioning, velocity, and timing of the GNSS instruments or systems. And the cooperation will also enable more effective space weather alerts by utilizing the real-time data from both regions. Thank you very much for your attention and your time. Thank you.
Thank you, Solomon. Samuel. Yeah. Thank you very much. That was a very, very, very excellent presentation. Wow. You have a lot of results already. So good luck with your PhD. Is it PhD you are doing or? Yeah, PhD.
Yes, please, PhD.
Virginia, you still have one more student, right?
No, no, Samuel was present for both of them.
Oh, okay.
Both groups.
Okay, because you say that I only have 10 minutes.
15 minutes, yes.
Yes, 15 minutes.
We don't want to keep people waiting and to keep to time. So we go to the next item, which is the update on everything about CONGA. So the internal updates that we have. Oh, sorry. Let me know if there is any question. Do we have any question for Samuel? Samuel is a PhD student that is trying to develop his dissertation, and this is one way for him to train and learn more about his work. So if you have any question or any curiosity about his results or his objectives, let us feel free to ask some questions. We have 5 minutes for that. So Samuel, you have that result that shows enhancement, or you call it intensification of electron density during some time. Are you also looking at those small scale structures? Because I saw a lot of small scale structures. Maybe it would be nice to also check those small scale structures at some point.
Okay, thank you very much. I think as we are in a group, we will take a consideration about that and check about that. Thank you for
Yeah.
that note.
Yeah, because if you see the time of the enhancement, I mean, of the geomagnetic storm, you start to see those small scale structures appeared around after that time of geomagnetic storm. So it will be a good thing to look at. Anyway, so
Okay.
any other question for Samuel? Okay, thanks again, Samuel. Thank you very much. And
thank you too.
Yes. So we are continue to push for funding for for CONGA, and one of the ways we have done that recently is to apply for internal funding from SRI. So SRI has a program that is called we call it IRED, and that is a kind of program that has to do with submission of ideas, cogent ideas from staffs that are working on some very important projects. So we have put in the proposal to develop a prototype. If we are able to develop that prototype, it will serve as enhancement for any future application for larger funding. So hopefully this come to this. So the funding is the proposal is about designing this prototype, one of them, and making sure that it's ready to go. We have all the technicalities because this is on paper. We want to build this, and in physical, we want to build all of these components if the RED is accepted and awarded. So that is one internal development that came up this last month. And then another one that came up is the DICE proposal. See that's DAISY proposal. Leslie, do you want to go for this one?
Sure. So NSF has a opportunity for distributed instruments called DAISY, DASI.
Yes.
And it is a award that is designed for distributed networks. This is a distributed network, so we are considering the viability of applying for some funding to do some initial deployment. With it probably, well, no, it definitely wouldn't be the entire envisioned network, but it might be a good phase one kind of initial deployment, work out some of the kinks, whatnot, and get some initial results. But that is very early in development. And we'll see what happens with that. And as usual, anyone else who has ideas for funding avenues is welcome and encouraged to share them.
Yeah, thank you, Leslie. So yeah, like I said, we won't want to waste people's time, and we want to respect everybody's time. And so we will go for open discussion. So if you have any idea or contributions that you want to hear for everybody, please feel free. Feel free to do that. So this group is very important because we try to build the network of people that can work together. So if you are not saying something, we don't really know how we can get to know you. So if you have anything in mind, or any way that can be of help, or anything on your research also that you want to present, it may be on science, just like Samuel did. And that was a fantastic example of how to present science on this kind of platform. And then if you also want to present instruments, next month's meeting, we have a presenter already. He was here, maybe he's still here, and he's from Japan. And so,
Yeah, I'm here. Yes.
yeah, excellent. So that's, I want to know you, try to.
By the way, may I ask a question
Yes.
about the instrument? So I saw the funding 90K. I suppose this is 90K US dollars. But how much is this 90K for, I don't know, 100 units or 10 units? How many units and what's the total funding required? And
Yeah.
is that funding including the installation or only the equipment? And also, I would like to know if it's available. How about the operation and maintenance? So it's a quite big question, but just to have a, because next month I will prepare, I will present on the equipment. We
Yes.
are saying the low costs, some sort of, yeah, there's something very much similar, but we don't have we didn't plan for all the power supply and remote, this type of things, but it's simply the receiver system.
So I will let
Yeah.
Todd answer your question, but just to chip in that this is not just the receiver, it has to do with all of the equipment,
Yeah.
solar panel,
Yeah.
all the equipment in the box,
Yeah.
control, battery, and many other things that comes with it. So, but this is internal. This is not anything standard for now. It's not a standard price or anything, but we are just proposing this internally with
Yeah.
SRI to enable us familiarize ourselves with what we want to sell, or what we want to deploy to these places, so that we will know that we are certain we can place a label on it, that this is the expiring date, this is all those things will be identified. Oh. So, Todd, if you want to ship in something.
Sure. Yeah. So all of the things that you were mentioning aren't covered in that initial estimate. So it's not for building a large number of units. It's not for deploying them or anything like that. It's to do the prototype design and kind of play out in the trade space of how small can we make it, how inexpensive can we make it, and how easy to deploy, how simple or complicated. So kind of covering those things, getting a couple of units, prototype units built, and just having them run. So then we get some estimates of what lifetime issues are on them. You know, do they overheat? Do we have any environmental concerns and things like that? And really getting a good sense of how ready the technology is for them when we do propose to build a large number of them. We can say with good confidence, based on some hard numbers and solid designs, that we can go ahead and do it. Right now, that we're starting from nothing, saying, sure, we can design something and deploy them. We want to take that risk out of that first part of that. And so that's kind of what it's just, it's an internal research project to kind of build some of that instrumentation, do the mechanical design, but it does cover multiple power systems, communication systems, the mechanicals, and things like that. So as you're mentioning, it is a bit more than just the receiver.
Yeah.
Excellent.
Yeah. I think it's a full complete system. Yes. Yeah.
Yeah. So we're just trying to minimize some of the initial risk when we do a larger proposal by saying we actually have built and know some of the ins and outs of what's going on.
Yeah, and CONGA is about, okay, we give you this instrument, you are not going to do any other thing. You just plug and play. That is a kind of settings that we want. we want to get to. Like that is the purpose of this initial project. We want to, okay, this is what we have and we want to distribute this, but you'll be able to operate it by just plugging it and it start works. We start receiving signals. So far you have internet in your place. So every other thing is taken care of to that extent. Yeah, do we have follow-up questions or any other questions?
Okay. Good evening. Thank
Yes.
you very much for this wonderful presentation. I just have a question sequent to what you just said now. You said that you just only need the instrument is going to be plug and play instrument, and just going to only need data. I want to ask, is it just the data the host institution is going to be providing?
I'm not sure I got the question perfectly, but the plug and play that I mean is that you don't have, like you have your phone, you need to charge your phone. In this case, you don't even need to charge it. You just, you have the instrument. If you are identified as someone that we host the instrument, we will ship the instrument to you and put it, what you need to do is just put it on your roof and plug it into this supply to whether it is I don't even think you need to plug it, so it's autonomous. Like you don't even, it doesn't need power because it has battery, it has solar panel, so it power itself. So yeah, so the data part of it will be transfer automatically as well. So it's autonomous. It's you don't need to do anything except that you may need internet. If your institute has internet, that will be fine. If it doesn't, depending on the funding that we have, we'll be able to provide internet that will. So you don't, in that case, you don't even need to do anything. Just put it on your roof, and that's all you need to do.
Okay. Thank you very much, sir.
Yeah.
Hello.
Yes, please.
Yeah, this is Patrick. Have you tried anything on, I mean, the budget of adding the internet provision of internet to the system and not what do you call without internet, and then see the differences if it will not be all that much?
Yeah, it's a really there is a big difference because we are using Iridium or Starlink. So there will be a big difference if we are not adding internet to it. So the best thing is that your institute has internet, and that will save us a lot of money. And because local internet is preferable than to other kind of satellite internet that we want to propose. Although it is being said that all these things are dropping down in price now, so that is also good news. But for now, there's a little bit difference in price.
Okay, I understand. When you said something like local internet, because I think for us to even use any satellite internet, you need to get the license from the local authority in order for them to assign the frequency to us. So we cannot just put any satellite internet just like that. Thank you.
Yeah, the local internet will serve in that case. So, for example, if you are in a university, most universities in Africa, they also have internet. And that will be very helpful.
Okay, thank you.
Mm-hmm. You're welcome, Patrick. And any other question?
Hello, good
This is
afternoon.
Dinesh. Sorry. Okay, go ahead. I will put my question later.
Okay.
Good afternoon, please. I want to ask if the local host will be able to have access to the data, I mean, like local storage for the data, or it's going to be transferred automatically to your database?
Excellent question. So, the design we have now is to transfer the data automatically. But if the local host needs the data, the local host can get the data in real time as well. So it's not, there will be no difference whether you get it locally or you get it afterwards. So it's going to be the same. But for efficiency, we will prefer that the data is transferred automatically and then it will be made available publicly.
Okay, thank you.
Dennis, please go ahead.
Okay, so I just want to put a comment, or it may be a question to our colleagues. And since we need to send the data to internet, I think we need to minimize the data size as small as possible. So at this moment, I'm not sure whether you are sending the raw data from the receivers and also some other data from the other sensors in the system, or whether you will send some sort of a processed data just to send the result, like the TEC values or like that, to the cloud or to the server somewhere. So my question is, are you sending the raw data as it is from the receiver or processed data?
Yeah, I think Todd, we may want to say something, but I think what we are going to be sending is the rightness form of data.
Okay.
So anybody can use that to the extent of which he or she wants or which they want to use it. So we don't have to worry about any kind of products. So what we want to supply to the global community is the raw data, which has to do to that level of rightness data. Am I right,
Okay.
Todd?
Yeah, I think the answer, it can vary depending on the quality of the communication link or how much data we can transmit, but there'll be certainly some base level, which as Olu was saying, the Rhinex format files at some particular cadence, whether it's 5 hertz, 20 hertz, something like that, whatever that data product is. Those would be the base one. For links that have better communications and higher bandwidth coming off, then you could easily select something that would pull more data for that. In addition, the sites do have some amount of local storage, so that if the network connection isn't always on, or if it's preferable to transfer at a particular time of day, if we don't need full real-time data, that we can buffer stuff up and still transfer it off. But looking at what needs to come off and the amount of data, I think that's part of that prototype experiment as well. And certainly any inputs on those kind of data products would be good to know as well. But there is a fairly sophisticated little computer that's in there that can do a lot of onboard processing, compression, data reduction, and things as we would need to kind of optimize that link that comes off. And I think one other question or thing that had come up was, in addition to local internet at a site, the in-between from that to the satellite connections is potentially doing a cell connection, cell modem, basically a cell phone type connection, if that's doable. All those communication links are independent of the system. You can handle all of those. So
yeah, excellent. So yeah, I believe that answered your question, Dennis.
No, thanks. Yeah.
Any other final questions? We are getting to the top of the hour.
Okay, hello.
Yeah, right.
Yeah, this is Patrick. This is not a question. Maybe it's another statement to, especially what Samuel presented. So it's like when you come to Africa, actually, there are many receivers, but the problem is like what my brother just asked, how to get the data is a problem. So the map Samuel presented, in Ghana, I think he showed only one receiver, but Ghana has actually more than 6, 7 receivers here. But the problem is, where do you get the data? So that also make the CONGA project more significant, whereby we are going to find the data at a particular point, okay, and then use it to understand the dynamics of the ionosphere. So that is what I want to say in follow. That actually there are some receivers existing, but it's difficult to find the data because you may not even know when you go to internet, you don't know who is operating or who is in charge of that receiver or whatever. And like I said, that makes CONGA so significant that by the end of the day, we are going to get the data at a particular site where we can use it to, do whatever we want to do to understand or build our comprehension concerning space weather, and then any other related research. Thank you.
Yeah, Patrick, you are right about data availability and accessibility. So it's a big problem, particularly over the African sector. And that is one of the problems or the objectives of CONGA. So for CONGA, we have a very large amount of distribution of instruments, and all of these will be available freely on the internet. So you can just go to IGS, you can just come to ISR website, you can just go to CEDA website. All of this data network facility, CONGA data will be available. So you are ready to do science at the go. So yeah, that is, and also we want to encourage people that are having data but holding it to themselves. It is time to allow science to be done in the free world, right? To the point is that everybody use other people's data. For example, we use geomagnetic data. Some people are responsible for making this data available. And when you get your own data, you keep it to yourself. I think that is one-sided kind of. So I will encourage us to make our data available as much as we can so that other people can use it or be useful to the community or the global community at large. Thanks, Patrick. Any other
So
final
in
comments?
the data sharing, so I just remember one more important point, because we have deployed the GNSS receivers in basically in Asian countries and in 2 African countries, Mozambique and Rwanda. And some countries, they have a government regulation, that they can provide the process output like the position data or some other like a TC, but they can't provide you the raw data. So I wonder in this project whether you have explored about the country's regulation related with the distribution of the GNSS data in the raw format. That may be one problem, like sending the RINEX data may be not allowed by the country's regulation. So I'm not sure the condition in Africa, but we have this condition in some Asian countries.
In some Asian country, I see. So that is one of the purpose of making this autonomous. Nobody have access to that system except that you put it on your roof, and that's all you need to do. And the data will just be sent, whatever kind of data we want to send will be sent, and then will be made available to the global community. So there is no.
That was my question. Can you do the global access from a receiver that is set up in some specific country? Like you have a receiver in Ghana or Nigeria. Is it allowed to send the data to the global community?
Okay, hello.
That's my question.
Hello.
Patrick, please go ahead.
Okay, so I'll come in here. I think in Africa, when it comes to data, we don't have that such clause, because already there are some receivers, like I said. When you go to Africa website, there is a receiver in most of the Africa countries, okay, that they receive. When you go to IGS, there are receiver in most of the Africa countries. And we've also met in so many programs that we talk about receivers and then data. So there's no problem about that. The problem is the assign of a particular frequency. And that is what we, Dr. Jonah responded to it when we were talking about adding internet to the receiver, okay? Satellite internet to the receiver. So actually, Africa, I think we don't have such clauses.
To add to that, I think for Africa, the problem is not government holding up the data. You can have 1 or 2 countries that government want to hold the data, but that is not that prominent.
Hello.
So the problem.
Hello, please. Can I come in?
Yeah, please.
This is Francis, also from Ghana.
Oh, excellent. Go ahead, Francis.
Okay. Yeah. I appreciate what my colleague said, what Patrick said, but I want to hint you that the government officials, the top-notch government officials, sometimes are not in favor of we sharing data straight from Ghana to the international community. I had meetings with the Minister of Environment, Science, Technology, and Innovation. On 2 occasions, he registered his displeasure, about that. So when they get to know in future the details of some of these things, they are not experts in it, and so they don't know how it goes. So it's like, but according to him, there are certain things that have been going on behind them, and later when they hear of it, they are not happy. Yeah, you have data collected about them. That is how he put it. Data collected about them, and then that data is sent away. That data is not monitored. It's not how do you call it, scrutinized, and then the data goes, whether it has some security implications or not. Then it goes, leaves their setup. Fine. For me as a science student, I understand. Understand the importance of the exercise, and so it can just go straight away. But I just want to let us know that some government officials are not very happy when data is being sent straight from by way of internet, to other places without being how do you call it, checked. Yeah. So just to let you know that there are some objections in some quarters, but it is not public.
Okay. Yeah, that will be take note. We'll be taking note of that challenge and also look into the countries where we will have these challenges and try to see the distribution of this, whether it is large countries or small countries. Maybe what I mean by that is if these countries are more than 5 or more than 10, like that, so that we will know where we are. Technically.
Then one point of interest is that sometimes they wish citizens are taken through how the data is processed, how it is utilized, how it is applied, and how the country can even get the insights, about what the scientific investigations or research that is going on and how beneficial it is to the country. So for them, it's like if you collect data and then you send everything out over there, okay, you say it is in global domain, then the people, citizens who, were used as conduit to get the information, they don't get to know how the data is processed. So I think our first meeting, I indicated that we need to know how, there are experts already who knows how to process these things. Those people can serve as resource persons, in a workshop or seminar or something. And people must be taught how to utilize, especially those of us in academia, must be taught taking through the data structure, taking through, how do you call it, how to process the data, how the softwares that are involved and all that. Some time ago, I joined, not only once, about 2 or so times, I joined those in, they were having a similar thing in Nepal or something. I think the facilitator, professor from Japan, I think, was the main organizer. And the time that it was being held, it was convenient time for them, but it was midnight in our part of the world. And so it was not conducive to even take part, and some of us didn't get flight ticket to join them in Nepal or wherever and participate in the hands-on. And so if Africans have been involved now, you must have a workshop, hands-on workshop for them so that they can also learn how to process some of these things. Since it is, it's a long distance traveling all the way to Nepal or wherever, or Japan, and the flight tickets might be too expensive for the organizers, to sponsor you. Thank you.
Yeah, thank you very much, Francis. So I think we need to go now, but I will say that scientists in Africa have a lot of work to do in getting the government to understand that this is data for science and not for political gain or anything. So the fact that they still hiding in that shadow of maybe they want to use data for something or something else, where other data. Okay, sorry, Patrick, let me finish up. Other data from other countries, even more advanced countries, are available on net. So when I show that map, the map that I show constantly at the beginning of this talk, you will see that this is a global map. And these data are available globally and that is why we have access to it, and that's why we can do that plot. So saying that people cannot access your data because you think they want to use your collect your information, why are they allowing you to collect their own information if that is the case? So I think scientists have a lot of work to do in getting their government on board to understand this basic science objective. And that is when something like CONGA can strive. So, yeah.
Maybe point of correction, point of interest, please. For instance, GNSS is available globally. Global navigation satellites, data. So you can navigate wherever you are going, but US has certain, how do you call it? Data types that you cannot not access. Only the American security, the Air Force or whichever institution, they can access those things. So it is true, some data can be made available, but from the raw data, some can put some kind of coding, depending on programming language that you're using, they can restrict certain information from going out. Some advanced institutions, advanced countries have that capability of restricting some data, but leaving out some data. So it is true, what he's saying, there are some data that if all the raw data is coming out, some data that is collected can be unpacked on, how do you call it? It can be processed by the advanced nations because they are highly advanced and they know a lot of, you don't know how to go about it because they are even the owners of that software. So they know what to restrict and what to bring out, and so on and so forth. So in fact, he gave me a lot of...
So the problem is still there, Francis. So the problem is that there is nobody monitoring anybody, and satellite data, like you said, are there rovering over everywhere. So if they want to monitor, I think it is satellite data they will use to monitor. It's not the ground-based data. So the bottom line is that the scientists in Africa need to propagate this simple, basic knowledge of understanding to government in the country. I'm from Africa, I'm from Nigeria, and I understand how these things work. So the bottom line is still scientists needs to, and if scientists does not understand it, how would they propagate it? So the data is ground-based data and it's made for science. Bottom line is that we don't want to do government work, and the ground-based, if I'm in Africa today, I'm able to download all of this data and I will still plot that map that I showed you in the beginning of I will still plot it in Africa. For example, I will plot that map in Africa, and the whole in Africa will still remain just because of this premature or primitive knowledge of how data will be used. Is limiting the African sector or the African countries in basic science. We want to understand basic thing and scientific thing over the equatorial region. We are not able to do that because of all this. So I think it's high time we get on board to make data available for people, science students that wants to use them. For example, you have data and you hide it. Somebody wants to do science and he cannot do science because you are hiding your data, just because of one fear that somebody will spy you. How many spy satellite data are there? If they want to spy, it's very easy. I think scientists need to do more work than what they are doing right now. Anyway, Patrick, could you give us a very quick one?
Please, this is brief. Mr. Kujo, this is a research data. This is not a security data. I don't know why, what do you call it? Maybe we have to discuss the research data with, ionospheric research data with a minister or any other thing. Because in Ghana, for instance, as you are talking about, every university or every research institution is an autonomous body. For example, I have Japan instrument here, or sky imager, that I'm using it to observe plasma bubble in the ionosphere. I did not even discuss with the university vice chancellor. It was a departmental discussion, and then later they forwarded it to them. So I really don't know if you try to use the RINES data or the research data, discussing it with ministers, and then I think we are going far. And research is allowed. And like I said, the university here is an autonomous body. Likewise, every research institution. And already there are so many receivers of GPS and then other instruments on internet that we download. So I think it doesn't get to the politicians who are spending 4 years and then whether they will vote for them again or not, to decide for us whether we should, we shouldn't use some instrument. How many years are they spending? So let us be careful about the utterances we make when, we gather like this. Us, it's like we deem the countries some kind of, image as if we are not open for research or something of that sort. The security data is different from research data, please. And I think it's allowed for us to work with.
Yeah, this is just a very good discussion to have, and we appreciate everybody's contribution. So we look forward to more of these contributions, and we can discuss more to broaden our knowledge. And if there is a way we can educate our government in our countries, let's do so. And while I will be, if I could say this, if this kind of less understanding exists between the science community, that would be very sad. I think the science community has a
Jonah,
duty to
sorry to
educate.
interrupt you.
Okay.
Point of correction. The one I, for one, I'm how do you call it? I've been doing a lot of outreaches. I do outreach even on television and radio. I've been doing outreaches in schools. So I'm one of such people I'm like an evangelist for science. Excellent. When I meet the minister, when he was expressing all those things, I tried to correct him. In fact, I tried to convince him. At one point, I was there with my vice chancellor. I tried to correct him. And so it is wrong for my colleague, Patrick, very good friend, very tight friend, to be telling me that I shouldn't be bringing it out, on this kind of platform. I'm only telling you the misconceptions in the, in the system. I'm not against it. Otherwise, I wouldn't have joined this network in the first place.
Thank you.
I am for this, this project. Otherwise, I wouldn't have been joining this. I wouldn't have joined this network in the first place.
Thank you.
Just to let him know that there are misconceptions at the top hierarchy, and we as science people must come together and correct it.
Yeah, I know. I think I understand where you are coming from, Francis, because you have dined with the people in authority, so you know better, so to say. So I totally appreciate all your comments, but the fact that you mentioned that you are educating them, that makes me, very, very happy. So and that is what we are here to do, to get information on how to move forward with CONGA, because all of this may look like something like an hindrance, but it's not. It's just when we go out now, we will be able to analyze all these comments and work on it. So if we go to Ghana, we know that we may be facing this challenge or challenges that is already stated in this meeting. So it is, everybody has the platform to talk. So feel free to say whatever you think is right. But what I thought you were saying was not what you were saying, in the sense that scientists has that primary obligation to educate the government on what this is all about. And you have just mentioned that you are doing that. So thank you very much for all your efforts. And I think we should just end this meeting at this point. Thank you all for coming. We have spent our time a lot, and we appreciate everybody. Thank you.
Thank you very much.
Yeah.
Thank you.
Yeah.
All right, thank you very much.
Yeah.
Thank you, everyone.
Thank you, everyone. Bye.
Bye, Inga.
Thank you.